Hello, and welcome to my NimConf 2026 talk. Frag, a Nim game engine. I think that's what it's called anyway. I don't remember what I told the moderators, so we're just going to go with that. Um, my name is Zac, for those of you who don't know me, which is probably almost all of you. Um, I started programming in Nim in like 2015. I think that's when I tried to write my first game engine in Nim, and I had no idea what I was doing then, and I still have no idea what I'm doing now. But I appreciate you showing up to my talk, and I hope I don't disappoint you too much. But I'm going to kind of tell you a bit about my project, why I picked Nim, and show it off a little bit for you. So yeah, I chose Nim for game engines and game programming because I didn't know C or C++ way back when I started learning Nim, but I desperately wanted to, and I was kind of stuck in like Java, C sharp world, and didn't have a great bridge to. I didn't learn computer science. I wasn't like formally taught computer science in school. Um, but Nim offered a great on ramp to lower level programming languages for me. And I think the FFI story of Nim is what attracted me to it most first. I didn't really care much about like metaprogramming back then, or um, I guess Nim's garbage collector was another selling point, like a non-stop the world GC. Um, those were, I think, the things that mostly attracted me to Nim back then, and are still, attractive points of the language now. But for game development in specific, there's so many C and C and C++ libraries out there that you can kind of use to cobble together an engine pretty quickly, and that's what I've done, and I'm going to show off today. Another feature of Nim that I think is really appealing is the build system or lack thereof. I know there's like Atlas and Nimble and different package management and build tools out there, but I don't use Nimble or Atlas or anything. I basically have Git submodules in my project for dependencies, and then I have a config nim script file and a whole bunch of tasks defined in there. And those tasks are used for like building third-party dependencies, building plugins for my game engine, and I'll explain those in a moment. Building the engine itself, um, compiling shaders, building different tools for the engine, all sorts of different things like that. I mentioned plugins. So the engine itself it's a plugin based architecture, and if you don't know what that means, uh, it means that the host program, which is the game engine binary that all the game engine code compiles to, will accept a command line argument telling it where a plugin exists that it should open and load symbols from. And a plugin is just like a shared library that exposes a C API. It can be written in any language that can produce a shared library with a C API. So you could write a plugin in Rust or Zig or C or C++, whatever language. And you can use plugins for writing games. You could use plugins for writing uh, desktop applications. You could use a plugin for modifying a game. You could use plugins for just extending the engine or your game code with some feature you want. And that's really what the engine is. It's a whole bunch of plugins that can be uh, optionally enabled or disabled. Another really cool thing that the plugin architecture brings to the table is the ability to hot reload code. So um, I have a C library that I use called CR. The header file is called cr.h. I think it just stands for C reload. Um, but it will allow you through an API to load hot reload code from plugins, unload them, preserve state across plugin reloads in a static section of the library. Um, it will allow you to roll back versions of plugins. So you can tag a plugin with a specific version, and if for whatever reason you encounter a fault, it'll roll back to a previous version. You can create dependencies between plugins, and then resolve that dependency tree. Um, so yeah, it's quite a powerful architecture if employed right. And I have a whole bunch of plugins, that I use in combination to build the game that I'm going to demonstrate. So um, yeah, to start off with, I'll just fire up the game using the engine. The game that I've been working on, it's called Shell Shocked, and I'm going to run the engine with there's a couple ways to build the projects with the engine. One is in like a debug mode, which I'm going to demonstrate now. You can also make a bundled release, and in a bundled release, all the libraries are linked statically. There's no hot code reloading. Um, you get a larger binary, but you don't have to distribute all these shared libraries for plugins and everything along with your binary. Um, but for now, for this video, I'm just going to demonstrate the debug build with hot code reloading. There is bundled releases already published up in the engine repo, but um, I'm still in development with my game, so my primary path has been this hot reloading debug build. So here's the game running outside of the editor, just a standalone build of it. It's a real-time tactics game. The inspiration is the old Bungie game Myth: The Fallen Lords, but my game obviously takes place in a much more modern setting with there's no swords and bows and arrows, guns and grenades, and eventually vehicles and all sorts of cool stuff. Yeah. There's still some performance optimizations and frame hitches and stuff that I need to work through, but I'm not focused on optimization right now as much as I'm focused on just getting gameplay in at this moment. So yeah, it gives you kind of an idea of what I've built so far with the engine. So now let's fire up the editor. You do that very similarly. You just point it towards the editor plugin, and then your plugin can accept command line arguments. So in this case, it's going to accept an argument telling it what project file to load up. And it's going to load up with an empty scene. It's editor interface very similar to Unity or Godot or whatever. So first I'll just show off a couple different things about the engine. It uses an entity component system behind the hood, and if you don't know what that is, it's just really a way of like organizing data in memory. And there's benefits and advantages and disadvantages to using an entity component system in your game engine's architecture. Usually they perform better than like a game object component system like Unity has, where it's leaning heavily into object-oriented concepts and programming. But without getting too in the weeds, the way it works basically is you'll add an entity to a scene. And by default, all entities in Frag get a transform component. Now I can add other components to an entity, and components are basically bags of data. And then the game engine or plugins will query the entity component system to figure out what entities exist in a scene and what entities with what components exist. And then there will be functions or what entity component systems called systems that manipulate and carry out game logic on those entities and components. So for instance, I can add a mesh component, and then I can go pick a model somewhere. I'll just grab this cube model. And I will assign. Oops, I don't remember which. Hmm. I think maybe there was a bug. Okay, I'm gonna load up a different scene. Okay, well, let me try a different model. Um, no, really doesn't like that, huh? I'm not sure why the static mesh isn't working. Try to load up a different scene. Okay, well, I'm doing this in one take, so there be bugs for sure. I'm not using many static mesh components. I am using some. Here's one, for instance, which seems to work fine, but I'll have to debug that after. Anyway, what I wanted to show was, let me go back to the scene. You can create prefabs, very similar to Unity, where you like have a predefined set of entities and components already arranged in a hierarchy. So for instance, we have a rifleman prefab here. And then I can spawn this prefab into a scene from code, or I can just drag it in from the asset browser into a scene. And then I can edit the prefab here and save changes or close it and get rid of it. Um, what else? Oh, you know what? That's why it wasn't working. The scale was all defaulting to 0 for some reason. Okay, so mystery solved. Um, Still a bug, but anyway, you can see I can manipulate and scale and rotate the component here in the editor using gizmos. Okay, let's go ahead and show off some other things. So there's a terrain graph editor, which you can use for constructing procedural terrain. And this is how the terrain in that level for the game I'm working on is built. So it's entirely procedurally generated through noise functions, different input bitmaps, splines, um, and it has vegetation scattering and everything. So it's quite powerful. We also have animation graphs, which currently have a bit of a display bug going on with them, but I don't really edit these things that often, so I've just been living with it, but it does need to get fixed. And this is where animations can be assigned and blended together, and you can have different layers. And we also have ragdolls. So let me open up one of those prefabs again. I'll open up the medic this time. And go ahead and move this out of the way so we can see the medic. Okay, so we can edit the ragdoll in here. It's kind of hard to see. Um, I had a way to hide the mesh at one point, but I need to add that back into the editor. But yeah, the engine does fully support ragdolls. There's ragdoll assets that get hot reloaded here. Another thing that I forgot to mention is all assets in the game are also hot reloadable. Shaders, textures, models. You can basically register callbacks for every asset type you register. So in those callbacks, you can say this is how you hot reload the asset. So like in the case of shaders, the shader compiler the engine uses, which again is driven through the build system. There's a task to compile shaders. Will generate reflection data for those shaders, and then the engine uses that reflection data to know how to hot reload the shader when the compiled shader file changes and the reflection data changes. Um, yeah, there's a big post-processing plugin too. So if we go back to this scene, that's how like the color grading with a lookup table works, and all these nice visual effects like the outlines on geometry work and the tune shading and everything. Trying to think. There's a fiber-based job system. This is actually a pretty cool feature, I think. So remember, this is a debug build, obviously not running at the highest frame rate possible, and definitely not even close to fully optimized. But let's say you do want to do some optimization work. Well, first of all, you can open up the profiler here, and you can also see um, all 16 worker threads that the job system uses. And right now in the editor, just the main thread's getting work and saturated. But if I press play, all of a sudden you're going to see all of these worker threads get saturated with work. And that's because different tasks, like for instance, physics simulation is running on worker threads using the fiber-based job system. Um, so the engine is taking advantage of all the cores, and you can check that here. Um, Another cool thing you can do is there's a C++ profiler called Tracy, and if I click this connect button and I have a profile build of the engine built, which I do here, and click connect, you can see the profilers shows connected up here, and now I'm capturing uh, different profiling information that I'm omitting from my engine and plugin code. And then I can stop that and save the trace, and I can zoom in and see what's taking the most time to render um, using a flame graph. And yeah, this gives you all sorts of interesting profiling information that's helpful for finding ways to optimize your engine. Um, and now it shows I'm disconnected again. So that's another neat feature. Um, so you have a gib system, so you can, detach bones and spawn gibs if you want to like decapitate a unit when it gets shot or something like that. Um, Custom materials with custom shaders. Um, so you can come in here and edit a material, change all sorts of different properties that the shader exposes itself. Um, what else? What else? What else? Talked about prefabs, sounds, obviously, and VFX as well. I actually have a bunch of VFX wired up right now, so I think if I press 1, I gotta be in play mode probably. If I press my number keys right now, I think, yeah, it'll start making explosions. Because I was porting over VFX from Unity and testing them out by wiring them to the number keys. So, but yeah, the game itself is a plugin. The editor is a plugin that loads the game. You can actually change properties in here while you're playing. For instance, I want to close this. I go to the inspector and select this APC, for instance, well, it keeps reverting to the scene, but where this is really handy is like playing with post-processing stuff. For instance, if I come to the camera, come down here and I turn off like the outline, I can see what the scene looks like with that, without that enabled, right? Or turn off, cell shading. It looks completely different, right? So lots of power there in terms of being able to see changes and iterate quickly. But I think this presentation is getting pretty long, and I just kind of wanted to give a basic overview of the game engine, and give my thanks to all of you, the Nim development team, Andreas, and all the moderators who are putting this conference together, and thank you for giving me the opportunity to share my project. If anyone wants to reach out to me, please feel free. I'm in Telegram. My handle is Z in there. Alternatively, I'll put my contact information in the video, or at least my form handle or something. I don't want to dox myself, but yeah, I'll leave some way of getting in touch with me. And thanks so much, and happy NimConf.